YouTube channel. So now we're going to be looking at the Huawei software, which is the eNSP, which is the network simulator. So we have looked, I got videos that I was covering the basics of Cisco Packet Tracer. So now we're looking at the eNSP, which is like similar to the Cisco Packet Tracer, but this one is for Huawei. So it's a network simulator. Like it is owned by Huawei, and then as you can see, we have like different routers, different devices that we can add here, and then you can run different configurations. So if one, like let's say you are preparing for a Network Plus exam, you're preparing for HCNA exam, this is the software that to go for if you want to learn networking, like especially if you're doing like the Huawei certification. So if you want to run different configurations, you need to download eNSP, which you download it from Huawei.com, which is the Huawei website. So I just want to take you through how to configure different devices, like the commands. So if you're coming from Cisco Packet Tracer, if you've been using the Cisco commands and all those things, they're quite similar. It's just that there are a few changes. As you know that networking will remain the same, right? Like it's just that when you're switching from one vendor to another vendor, they have like their own way of doing things. But in general, some of the things will be the same, right? So this is the this is the eNSP, right? eNSP software. So now let's try to add devices on this platform, right? So let me say new topology. Click on new topology. It will allow you to start your topology or create your network. So for example, let me start with this device. As you can see here is the end devices. If you click on this, this is where you find your end devices, which is quite similar to what we saw on Packet Tracer. And then the router, you get all the different types of routers, AR21, AR1220. So these are the different types of routers or different versions of routers that Huawei owns, right? So they come with different ports and then different capabilities and stuff like that. And we have the switches, different types of switches. You find this one is what, a multi-layer switch with how many 24 ports, and then with what's the speed, 1000 base T Ethernet, and then there is another one. So these are the switches, and here's what we have, the WLAN part. If you want to configure your WLAN, this is where you find anything that is to do with wireless. All right, end devices, and then cloud hubs there. And then here's the medium, right? Like if you want to add any cables, similar to Packet Tracer, if you want to add cables, if you want to connect devices together, this is the part where you go to. You can see if it says auto, just know that basically this eNSP will decide for you which type of cable you're going to use this side to connect devices. And then with the serial cable, E1, ATM, CTL, POS, and then the copper cables. All right, so let's say now you want to add devices, you want to build your own small topology. So let's say I'm adding my PC here. Let's add a PC. Let's add another PC right on the side. Okay, and then we want to connect these two devices together. Definitely, you know that now we need a cable, right? We need an Ethernet cable for this. So we know that a network consists of two devices connected together, either using cables or wireless. So cables can be Ethernet cable, can be coax cable, and then it can also be wireless, any type of cable, right, that can allow these devices to communicate. All right, so I'm clicking on the cable so that I can choose which cable I want. Like same with Packet Tracer, if you're not sure which type of cable to use to connect these two, I think you can click here and then the system will decide for you what type of cable to use. There, see, and then I click there. So you can see these PCs, they only have like one port for Ethernet, Ethernet port, and then also this one is one Ethernet port. Ethernet port 0/01, that's the port that is being used there. And then to get rid of these, you just click left click or escape, and then yeah. All right, so I have these two, and then this PC, you can move them around, you can push them to the top there, and then also here, if you want to type, let's say maybe you want to type the network that you're going to use, 192.168.10.0, say maybe just last 24. You can also do that there, right? And then you can see now these interfaces down on the packet tracer. We don't have this, right? Like this part is only on the router side, whereby it shows you that the PC is down, like it's off. You need to switch it on. Not switch it off, like the interface is down. It means that the interface is down. All right, and then in on this platform eNSP, if you want to switch on these, you can just highlight them and then you click there. Automatically it will switch on these devices. You can see now it turns to green, meaning that the interface is up now. All right, let me double click that so that we can assign IP addresses to these two devices so that they can be able to communicate. Okay, so it's just two devices. They are in the same network. They can communicate. They don't need a router or a router, depending on how you pronounce that. So they are in the same network, so they don't need that router. Host name, give it a name. Let's say it's written there PC1. And then the MAC address, you can see it's MAC address. And then static, meaning that you are manually assigning an IP address to this device, 192.168.10. This one is PC1. We're going to make it a 1. And then subnet mask 255, and then 0 in the end. What else do we need? We don't need a gateway because it's just the two devices that are directly connected. They don't need to go through the internet. And then let's say apply. So we've applied that. On packet tracer, you don't have to click apply or anything. Like once you type in the IP addresses, it's applied automatically. But you have to type them. You have to click apply. Let's say 192.168.10. So PC number 2. So just make sure that they are all on the same subnet, right? So that they will be able to communicate 255.255.255.0. That's the subnet. That /24 represent that's 255.255.255.0. Okay, that's the basics there. We say apply again. Close that. So I want to ping. So we use ping command to test connectivity between two devices. So for now, what I want to do is I just want to test connectivity between these two devices. Are they able to communicate? If I manage to connect these properly, and then if I manage to apply or assign IP address, correct IP addresses. So once they start communicating, then I'll know, okay, my network is working fine. So when building every network, you got to test your network once you're done, right, to see that everything is working. Okay, so what I want to do also is I want to use a Wireshark, right? A Wireshark is a tool that we use to to analyze packets, to check the packets that are traveling on these lines and stuff. So we are more like eavesdropping, listening to whatever is traveling on this part. So here you just right click on that part and then you say remove connection or start data capture. So I want to capture that data that will be moving from this part to that part. The data that I'm capturing is the packet tracer part, the ping messages that I want to capture here. So I want to see what happens behind the scenes as these two devices are communicating. What happens? What's the communication? You can see now Wireshark is fired up. So Wireshark is a network analyzer. So you just want to read what the messages that the computers are sending between each other. So now just waiting for Wireshark to complete the process, the starting process there. And then once it's done, then I will be able to move that side. Okay, let me see. I have that. Where is Wireshark now? I think let me do this. Just close this for me. Okay, quit that. I don't need that. Yes, quit that. I have a packet tracer there. Okay, so packet tracer, once whatever activity that will happen within those two devices will be able to capture, and then everything will be here. All right, let me go back to packet tracer. Not packet tracer. I'm so used to packet tracer. So this is eNSP. Let me move back to eNSP. Okay, let me, and then when you want to type in ping, you see like we have these tabs here. We have the basic configuration. This is where I configured my IP address. And then the command, this is where like the CMD part is on the PC. MC packet, all of these packet, UDP, unit data process, and then console. If you want to console directly to the router, this is the part where you like you go to. Okay, so I'm interested in this part for now. Ping. Okay, P. What am I pinging? That device, next device. So I need the IP address of that device, which is 192.168.10.1. No, it's not a 1, it's a 2, because this one is 1. I'm on PC1 now. All right, PC2. So I want to see what happens on layer 2, right, which is the data link. So pinging 192.168.10.2 data bytes, press Control C to break, and then say from. See, when it says from, it means okay, this is coming from a message coming from IP address 192.168.10.2. So this means this is a reply. So this PC2 is replying now. So we know that ping rely on different other protocols. So let's check out now on the Wireshark and see what messages were they sending. So we want to go behind scenes and find out the communication that the computers, the message that the computers send to each other when you're typing in ping. Okay, let me see. You can see here, Packet Tracer was able to eNSP. This is Wireshark. Wireshark was able to capture this. So the first message, let's see, it shows you the source and then the type of device, Huawei. So destination, it's a broadcast message. We know this is a message going to all devices that are connected to that network. So broadcast is it's an ARP protocol, address resolution protocol, and then the length is 16. Info, who has 192.168.10.2? Tell 192. So this is the message coming from PC1, right? So who is 192 is asking like all the computers that are connected to that line, okay, who's using this IP address 10.2? Please tell 192.168.10.1. So let's say now there are maybe 20, 50 computers that are connected to this network here. Maybe there's a switch and then all of them are connected to one network. And then all of them, they are going to receive this broadcast message. But the rest, the other devices will discard that message. They will drop that particular message. Only the device, only the device that is this IP address 192.168.10.2 assigned to it is supposed to respond. The rest will discard. It's like someone else calling you. Like let's say you are in class and then the teacher calls your name, right? Everyone in class they're going to hear that the teacher calling you, but just because the teacher called you using your name, right? So the rest of the class they're going to ignore that message, so they're discarding the message. They heard the message because it was a broadcast message, but they're dropping it. They're discarding, they're ignoring because it's not directed to them. So same scenario, same concept happens within the networks that are connected to the same subnet. All right. There it says 192.168.10.2 is 8. So you see, computer number 2 now is responding, and he's responding with his MAC address, right? Because we are on data link layer now. They need to know each other's MAC addresses in order for them to communicate. So there it is. He responds, and then this guy, computer PC1, will note, okay, this is the MAC address of this computer. Then they'll start communicating. So this is the Wireshark. This is how you can capture packets using Wireshark. So all of these, blah, blah, blah. Say, where is that part? Source, we have the source. We know who's the source. We know the destination. Okay, done. So this is the basic of that, what we call the eNSP, what happens within the eNSP. So now, let me see how many minutes have I pushed this thing. I don't want this video to be long. So let me just stop this one here and then try to do another one where we're configuring the routers and the switches. Okay, where is my platform? I can't find my platform. Okay, let me just do this. Right, let me see.